Hi everyone, I am Aishwarya Agarwal, working as a research associate at Adobe Research, India. I'll be presenting our work, Contrastive Learning of Semantic Concepts for OpenSet Cross-Domain Retrieval. If we consider any image query-based search system in a real-world scenario, it is possible to encounter queries that belong to object classes not seen during training. Not just that, it is also possible that the dataset used for training had images from certain domains, and the query comes up from a new domain altogether. To this end, we consider the problem of OpenSet cross-domain image retrieval, where query images come from both classes as well as domains unseen during training. The figure here visually summarizes our proposed SCNNet framework. As can be noted from the figure, during training, the input to our model is a cross-domain triplet of images where the anchor and the positive images belong to the same class but different domains, and the negative image is randomly sampled from a different class, which is a dog hair. The intuition behind our novel CEM module is that an image from an unseen class can be represented as a linear combination of local concepts represented by the set V here, where these local concepts form primitives that are common across classes. For example, a concept vector corresponding to a wheel will be used to build the feature representation for multiple classes such as a car, truck, motorbike, etc. We first get the feature map fx from the encoder and then reshape it to a 2D matrix. This enables running a singular value decomposition operation on the matrix that helps give an orthonormal set of basis vectors sorted according to the inferred singular values. We only retain the top k entries in these matrices to give us the feature map fk. We then use standard dictionary learning approaches to get the final feature vector fx and apply triplet loss on these feature vectors to help learn a discriminative feature space for retrieval. Next, I move ahead to the SYM module, which is for handling unseen domain images. Now, the goal of the SOM module is to map images belonging to different domains but same class closer in the feature space. Our intuition here is to calculate relative pairwise cross-domain feature distances and make them consistent with those calculated from the textual modality. This is what is mentioned in the loss function for the SOM module here, and the final loss function comprises of a weighted average of both the loss functions described in the CEM and the SOM module. Now we show some results comparing our proposed SCNNet framework with the baseline method for the task of OpenSet cross-domain retrieval. We can clearly see that our method outperforms the baseline by significant margins under all settings. We next show top 10 retrieval results for our proposed method and the closest baseline, and here also we can see that our results are much better than the baseline. We show TSNE plots where one can note a clear clustering of the cross-domain features from the same class. For example, in figure A, rainbow from the sketch and clipart domain are grouped together here. Similarly, dolphins from sketch and clipart are also grouped together, but form a separate cluster from the rainbow class. Plots 4D to 4F show how CEM learns transferable local features. Detailed explanations for these TSNE plots and the ablation experiments can be found in the paper. To summarize, in this work, we propose a novel framework for OpenSet cross-domain retrieval, which learns class-aware domain-agnostic local features and provides improved retrieval results for an image search-based query system. Thank you.